Muted.
And I just given a chat message to everybody. I hope everybody is able to see my. I hope everybody is able to hear my voice. Does anybody having an issue? Just give a reply on the chat so that I will start continuing on that. Okay, good. I think I got a good number of responses. Okay. So everybody is talking about Golden Gate and Golden Gate nowadays, and most of the companies are using Golden Gate. So what exactly the Golden Gate? Golden Gate is nothing but one replication tool. Okay. Like there are many tools are available in the market for replication. So, but most of the companies are using Golden Gate because of its advantages and whatever the industry is looking, those facilities we have in Golden Gate. So most of the people are using Golden Gate when they are in Oracle technologies. Okay, so the main advantages with the Golden Gate is one is a replication. I hope everybody is able to see my on desktop. Second one is zero downtime. Migrations or upgrades. And the third one is migration of databases across platforms, like different operating systems or different topologies, we can say. So like that, there are many applications. There are many ways we can make use of Golden Gate. So mainly Golden Gate we are going to use replication purpose, and the next popular one is zero downtime migrations or upgrades. Okay, and there is one more advantage with the Golden Gate is like heterogeneous. It supports heterogeneous environment. Like one database can be in Oracle, another database can be in SQL Server. Still, we can do migration of data between those two databases. Say, for example, this is the source database. This is in Oracle, and this is the target database. This is in SQL Server. So we can do replication between these two. So this is nothing but a heterogeneous. So we can have any combination. So that also supported by Golden Gate. So now I'm talking about replication. So what exactly the replication is? Say, let's take an example. I have one database called A, and I have another database called B. I want to synchronize these two databases. So whatever the transactions you are making on this database, the same has to be synchronized with the B database. So in order to achieve this one, we will implement a technology that is nothing but a replication. In order to sync these two databases like A and B, these two databases, in order to sync these two databases, we are going to implement a technology that is nothing but a replication, we can say. So replication means here syncing. So synchronize. Okay, so replication means it's nothing but synchronizing both the databases. The synchronizing can be done at different levels. That is at table level. Another one is schema level. Third one is at a whole database level. Okay, so based on our business requirement, we can synchronize tables also, or we can synchronize entire schema. So for example, Scott schema or HR schema or payroll schema, whatever the schemas you would like to synchronize, you can synchronize them. Or if you want to synchronize the whole database, okay, that also we can do. Of course, there are exceptions, like you cannot synchronize data dictionary related data, tables and particular schemas we cannot synchronize. Apart from that, we can synchronize that entire database. So in order to achieve this synchronization, just we are going to implement a replication. So that replication will be achieved using any of the tools provided, like a Golden Gate, or there are other tools like SharePlex, Streams. There are many other tools are there. Based on our business requirement and based on our budget requirements and based on our hardware availability, we can use different tools. So what are the tools available in the market? So mainly, most of the cases, like in particularly with respect to Oracle, we usually see one is Streams, second one is Golden Gate, third one is SharePlex. Okay. So let's go through the each tool and just a little bit about each tool, and we will see what are the advantages of each tool and what are the limitations with each tool. Suppose if you consider Streams, it's Oracle proprietary tool which is available from 8i onwards. Okay, and it comes with Oracle software. So there is no additional cost. So suppose if you have a license for Oracle software, automatically you can make use of Streams without paying any additional cost for licensing. No license is required. So it's a free of cost and no license is involved. Okay, so this is about the Streams. So it interacts directly with the Oracle database and it performs the replication the way how we need. And coming to the next tool is Golden Gate. This Golden Gate is Oracle acquired product. I think somewhere from 9i onwards, I think somewhere around 2008 or 2009 onwards, Oracle acquired this product. I'm not sure about the exact year. So since then, Oracle trying to promote Oracle Golden Gate rather than Streams, because Streams having some limitations which we are going to discuss in the later part of our session. So Oracle, this Oracle Golden Gate is Oracle acquired product, and there is a cost involved if we need to use Golden Gate, because we need to have a separate license for Golden Gate. I hope everybody is able to see my desktop. If anybody is having problem, just ping me on chat. Okay, and third one is we need to spend some additional money for that. Somebody's okay. Okay, so we need to spend some money for getting the license. Okay, and apart from that, this is an independent product, though it is Oracle acquired product. It's a separate product. It won't come with Oracle software. So there is a separation between Oracle software and Golden Gate software. So this will not directly interact with the database, but it will perform the replication. So we are going to discuss how it is going to perform the replication in detail in the later session. And third one is, so cost is, since the license is required, so we need to spend some money, so cost is involved. Okay, and the next one is Shareplex. So this is also used for replication, and for this also license is required, and the cost is also involved for that. Okay, so now the question is, like, since Oracle having a streams, then why Oracle acquired Golden Gate? Because there are limitations with the streams. The limitations are like latency is more. Latency is very high as compared to Golden Gate. And the second one is performance wise also, GZ is more far better than streams. Okay, so based on these two advantages, Oracle started promoting Golden Gate instead of streams. And from 12C onwards, Oracle de-supported streams, and it is going to deprecate that product completely henceforth. So we are not going to use streams for replication purpose henceforth, because it has been already de-supported by Oracle. Okay, so these are the main advantages with Golden Gate as compared to streams. And when compared to the Shareplex, Golden Gate, most of the features are almost similar, but only the main difference we can say it's a product is are owned by Oracle, so will have more support when compared with the Shareplex. So that is the main advantage if we start using the Golden Gate. Okay, so the next session, next topic we are going to discuss is I'm talking about the replication. So what exactly, what are the main advantages of replication in real-time scenario? So I'm writing on my paper actually with a digital pen, so I will have all the physical copies with me. Okay, now how the replication is going to be useful for us in day-to-day scenarios. I will discuss with you a couple of real-time scenarios. The first scenario is you have a database called payroll database, payroll or some XYZ database we can say. So on this we are running OLTP transactions and batch transactions. Say for example, OLTP transactions means mostly those will be very tiny transactions and which will last for in a microseconds it will be completed, but the number will be very huge when you when you are using OLTP transactions on any database. But whereas when you are running batch transactions means those will be very less, but definitely those are going to be resource intensive transactions. So if we combine both the transactions on a single database, definitely it is going to impact the performance. So in order to overcome that performance related issues, what we can come up with a new solution is that we can separate both the transactions into two different databases, however without losing any business impact, without any business impact. Say we will have one more database. This is the source, and we will create one more database over here. This is the target. So users keep performing their OLTP transactions over here. and we will try to synchronize this target database with the source database by using any available replication technologies. We can synchronize these two databases either at a table level or at a schema level or at a whole database level. So this is completely depend on our business requirement. So what we will do is we will synchronize these two databases online. So users keep continuing their transactions on the source database like OLTP transactions, and so as and when transactions are happening at the source database, so those transactions will be pushed to the target databases with any of available replication technologies, and we can synchronize this target database with the source database, and we can keep both the database at the same level always with low, as much as possible we can keep we can synchronize both the databases, and users can perform their batch operations on this database. So by separating these two databases, so what we are achieving is we are getting good performance at OLTP database. At the same time, we are able to perform all our batch operations on the target database, and with the up-to-date data, there won't be any delay in the data. I mean, there won't be any difference between the source and target database. Both the databases will have almost same database every time, and users can continue their batch processing on the target database, and OLTP users can continue their OLTP operations on their source database. So this is one of our replication scenario where we will use replication. And second one, we can say, I mean, there are many scenarios. Just I'm going to cover another one or two scenarios. And when we are discussing about the Golden Gate in detail, we are going to cover other topologies as well. And we are going to implement these scenarios as well as in our Golden Gate replication. I mean, when we are doing demos. And the second one is consolidation. Say, for example, I have there is a XYZ organization. It has multiple branches across the world. Say, for example, one branch is in UK, another one is in India, another one is in Japan, fourth one is US. So every division is having their own databases and their application as well locally. Okay, so and every database is having their local application over here, and this is also having local application. Okay, so their transactions keep happening it locally, but at the end of the day, we need to consolidate the entire data because management requires all the data to be consolidated at one location. It's their business requirement. So consolidation has to happen at target database, where management runs their business processing, business reports, whatever they need, they're going to execute on this target database. So it has to be done online, as and when any transaction happens in UK database, the same thing has to be replicated to our target database. So suppose some transactions are happening in India database, so the same thing has to be replicated to target database. Suppose if there is a transaction happening in Japan, the same thing has to be replicated to the target. And US, so the same way. So suppose something is happening at US, automatically the same thing has to be replicated to the target immediately without any delay. So how it is going to be possible? With replication, that is possible. Okay, so what we can do, we will implement some replication methodology over here, and we can achieve whatever business need. So business can continue their batch processing, like generating reports, weekly reports or monthly reports or annual reports, whatever it may be, they can directly run their target database over here. So without impacting any of their local databases, still they will get up-to-date information from all the local divisions. So this is one more scenario. There are many other scenarios, like just I will give you an overview of all the diagrams. Just give me 1 minute. I'm trying to share another document to give a better view about the other scenarios. Okay, I hope everybody is able to see a diagram. If anybody is not able to see, just ping me on chat. Okay, these are different other scenarios where we are going to use replication. Second one is, first one unidirectional we discussed, that is nothing but the separating the OLTP as well as batch processing. Second one is a bidirectional replication. Here we will have source database or one database in one location, another database in another location. So both databases will serve locally, but both will be in sync. In both the ways. So this is a directional. Bidirectional replication means replication happens in both the directions. So in the first scenario, the replication is happening from only one direction, so OLTP to batch processing. So, but here replication was not happening on other way, like bidirectional to batch processing to OLTP is not happening. But whereas in this bidirectional, replication happens across both the database and in both the directions. So peer to peer, like similar to bidirectional, but we have one more node over here. And broadcast. Broadcast means like one database will be distributing the data to different databases. So this is about the broadcast. And consolidation we already discussed. And cascading, almost similar to the broadcast only, but we will have one more level to avoid, to reduce the load on the primary database. So these are the different kinds of scenarios where we will use replication to achieve the business requirements. Okay, so now we discussed about what is a replication and where we are going to use replication, and now I'm going to cover how replication works in a generalized way. Okay. So now I'm going to cover how replication is going to happen. Say, suppose if we take Oracle database, generally how the transaction happens. So this is a database XYZ. And users are performing transactions like insert or update or delete. So what happens? This transactions takes place on this database. So suppose if there is any change in the data, automatically the changed details will be stored into redo log buffer. Okay, so once there are different scenarios, like when 1/3 of redo log buffer is filled, automatically those changes will be shifted to file called online redo log files, or we can say this one we can abbreviate it as a redo log buffer RB. And next one is, once suppose if the database is archive log enabled, automatically what happens, these transactions will be, these archive logs will, these redo log files will be moved to the archive log files. So we can say archive files. And which process moves from redo log buffer to online redo log files? Log writer will move all the transactions from redo log buffer to the online redo logs. And similarly, from online redo log files to archiving, it happens through archiver process. So this is a general database concept. So what happens when you are performing any DML operations or any change in the database like DML or DDL? What happens? The transaction takes place on the database, and the changes will be recorded at redo log buffer, online redo log file, or archive location. So any of these three locations will have the change details. Change detail means whatever the changes you did, like changing the salary from 10,000 to 20,000, or changing the address from XYZ to some other details, whatever it may be. Those transactions will pass through all these three stages, three places. One is redo log buffer, and another one is online redo log file. Third one is the archiving file. Okay, so what happens is that we will have some collector process over here. I will draw. Okay, here only. There will be a collector process. What it does is it collects the data from redo log buffer or online redo log file or from archive log file. From any of these locations, some collector process will capture all the committed transactions from here, and it will push it to target machine. So not collector, actually capture process, sorry. Capture process will collect the transactions, whatever happening on the source database, either from redo log buffer or from online redo log files or from archive log files. It captures all the changes and it will push to the collector which is running on target machine. So what it does is it keeps the changes over here in the form of some XYZ files over here in the target location. And here we will have one more process, apply process, on the target side. What it does is it reads all the files one after another based on the sequence, and it will apply to the target machine. So this is the general methodology happens in any replication, for not only in SharePlex, in everything, even in Golden Gate or in Streams or in any other replication tool. The basic idea is there will be one capture process on the source machine, and it will record, collect the processes, like it will collect the changes from any of these locations, like either from redo log files or in online redo log file, redo log buffer or online redo log files, or from the archiving files. It will capture the transactional changes, and it will push to the collector process which is running on the target machine, and the collector process will write them locally in a file specified by that tool. And there will be one more process called apply process on the target. What it does is it will read each transaction, like the files whatever generated by collector process, and it applies on the target machine. So in this way, it is going to synchronize both the databases, that is from the target, source and target databases will be synchronized by configuring the replication in this manner. So with this, we can achieve table level synchronization or schema level synchronization. Third one is DB level synchronization we can achieve. So whatever I explained in this screen, so this is general replication methodology. Okay, suppose if you see here, what we are achieving is we are capturing the changes at database level, at a logical level, we can say logical structure. We are collecting all the information at logical level, and we are applying those changes at a logical level only. I hope everybody is aware of two levels will be there. One is physical structure, another one is a logical structure. I hope everybody is aware of these two things. Physical level means physical database means like data files, redo log files, control files, and logical level means whatever the objects residing in the database. If we are directly making changes on those databases, on those objects, that we can say like a logical level we can say. So replication mostly happens at logical level. Logical level means we are making the changes directly at the table level or object level we can say. Okay, so this is the one replication. I mean, this is about the replication, how it happens in a generalized way. Okay, now we are going to discuss about streams, how it is going to be implemented, how it is going to implement replication. So whatever I explained over here, it's a generalized way replication. So I'm going to explain how streams is going to implement. So I'm retaining this space because I explained general way over here. So at later stages I will compare this diagram with streams also, so you will have a better understanding. Okay, now I am going to explain how it is going to happen in the streams. In streams also, like we will have source database over here, and we will have target database over here. Users are performing transactions over here, like insert any DML operation we can say, like insert, update, or delete statements over here. And as and when any user performs the changes, it will be recorded into the redo log buffer, and those will be pushed to online redo log files, and those will be moved to archive process. Suppose if we need to achieve replication between the source database and target database with the help of streams, what we are going to do is we are going to configure one additional memory component called streams pool. Streams pool. So this is a one memory component which we are going to configure in Oracle instance level. Generally it will be 50 MB size will be there. So we are going to configure this additional memory component in the database level, and we will configure one process called capture process on the source machine. So what it does is it is going to keep reading this redo log buffer, not already redo log buffer. So whatever the transaction, committed transaction happens, it will capture those transactions and it will push those transactions into queue. So this queue is built out of our streams pool, and this is available in the source machine only. So what happens is that the capture process keeps monitoring redo log buffer, this database. So as and when any DML operation happens, committed transactions will be captured by our capture process and it will push those transactions into queue. Okay, and on the target database, we will have, not on the target database, on the source database only, we will have one more process called propagator. Or propagation. So what it does is, it reads from this queue and it will send to the queue which is been configured at target level. This is a queue which has been configured at target level. Say, this is a source machine component. So like capture will be configured in the source machine and propagator will be configured in the source machine, and this queue is also, okay, this queue is also configured in the source machine. What propagator will do is, propagation will do is, it will monitor this queue. Queue means this one, Q1 I will say, source queue, or we can say. And whatever the changes comes to this queue, it will push those changes into the target queue. So the target queue will be on the target machine. So what it does is, it will push those changes to the target queue, and this target queue has been configured in stream spool, okay, which is in this target machine. So this stream spool also a memory component, okay, which has been configured in target machines, target databases instance. Okay, so what we will do, and for another point, what we are going to do is, we are going to configure another process called apply process on the target machine. What it does is, it keeps monitoring this target queue, and as and when it finds any transactions in this target queue, automatically it will pull those transactions and it will apply to target machine using this target process. Okay, so basically what it does, basically how it is happening in the shared pool is, we are going to configure stream spool in both the machines, that is in source machine as well as in the target machine. So there is an additional configuration has to be done in both the databases. That is similar to our SGA configuration. For configuring SGA, what we will do, we are going to specify those parameters, SGA underscore target and SGA and SGA like shared pool, and we are going to configure buffer cache and all those things we are going to configure while building a database, while configuring the database. Similar way, when we are going to implement streams, what we need to do is, we need to configure stream spool component in both the databases, that is in source as well as in target. After configuring that, we are going to create one capture process in the source database, and it will keep monitoring all the changes on the source machine. If any changes happens, it will capture those changes and it will push it to the source machine's queue. That queue has been built based out of streams underscore pool component in the source machine. Okay, and there will be one more process called propagator. Propagator also will be configured in the source machine, and what it does is, it keeps monitoring this queue which has been configured in the source machine, and it will push the changes to target queue. The target queue is in the target machine, and there will be one more process in the target machine, that is apply process. What it does is, whatever the changes appearing in the target queue, those will be pushed to the target machine and it will apply to the target machine. So here also the entire process happens at a logical level. And second thing is, second point is, we can synchronize data at a table level or schema level or at a database level we can achieve. Third point is, as I mentioned, there is no cost, no license. and this is about. And one more important point over here is the entire configuration, whatever I mentioned so far, like capture process or propagator or apply process, all these are built based on PL SQL code. Based out on PL SQL code. So when we are doing a PL SQL code, means what it happens is the entire PL SQL code will be executed either in the source database or in the target machine. Okay, so when we are running any SQL code or when we are running any PL SQL code, what happens, again it will interact with the SZA and it will perform parsing, and after that the regular process will happen, how whatever the process has been defined. So it keeps interacting with the database SZA and it will perform their operation. So there are many functions and procedures involved in implementing streams. So there will be n number of SQLs will be executed on the database. So obviously there will be additional load on source database as well as in the target when we are implementing replication using streams. So because of that, there will be little less performance as compared to other tools. The reason is it has to continuously interact with the database, and it has to perform its operation using source machine or target databases. It has to use SZ of either source or target databases. So that is a limitation with streams. Okay, now we are going to discuss about Golden Gate, how it is going to happen. Let me open another file. Okay, now I'm going to show you how replication is going to happen in Golden Gate. Here also we will have source database. And we will have target database. Users are performing transactions over here. Those transactions, any DML we can say, like insert or update or delete commands, users are performing. Those transactions will be reflected in redo log buffer. Once at certain intervals, those transactions will be pushed to file called online redo log file, and after that at certain level, suppose if the database has been configured with archiving, if the database is archive enabled, so those will be pushed to archive files. So the redo log file, like from redo log buffer to the online redo log files, log writer will write those transactions, and from online redo log file to archive files, archiver will write. So whatever the changes happening on the source database, the changes are available at 3 locations. One is at redo log buffer, another one is online redo log files, third one is archive log files. Okay, so in this Golden Gate configuration, what we are going to do is, we are going to configure a process called extract on the source machine. What we are going to do, what this extract is going to do, it is going to capture the information from this redo log files, online redo log files. So what it does is that it is going to capture all the transactions, whatever happening on the source machine, and it will push to a component called collector on the target. And collector, what what it does is that it is going to write in the form of trial files. See here, say for example, let's say files version. So actually this will be called as a remote trial files. So it keeps the collector, what it does is that it is going to write those changes to files called trial files. And here we are going to configure a process called replicate on the target machine. So what it does is it reads each file over here. One second please, I am pausing. Sorry guys, I'm back Moshe. Okay, so where we were, we have a replicate process on the target machine. So what it does is that it is going to apply those changes on the target machine. So here also, the similar way how it happens in the streams, the same way it is happening, just a little difference in the terminology on the process names. The main difference, if you observe, is extract process is collecting the transactions from the online redo log files. It is not interacting with the redo log buffer that is in the instance, which is in the instance. So what it does is that it is going to collect the transactions from the online redo log files, and it is pushing those transactions to the collector process on the target machine. So it is not directly interacting with redo log files. I mean, it is not interacting directly with the database. Okay, and the second one is in the target machine also. Sorry. Okay, so in the target machine we have similar process like one is a collector, another one is replicate. So what it does is the collector process will write in the local trial files, and it is replicate is going to apply, but there is no difference in the target location, but only in the source machine extract is capturing the changes from online redo log files, not from the redo log buffer. So this is the main difference with Golden Gate. Okay, and the second difference is the extract process or collector process or replicate process. These are background processes which are running from our Golden Gate software. If you remember, sometime back I mentioned Oracle software is separate, GG software is separate. So both are separate softwares. We will install Oracle software separately, we will install Golden Gate software separately. So there is no link between these two. So all these processes like extract process or collector process or replicate process, those will be executing from Golden Gate software, not from the Oracle software. And those are background processes, and OS level, those will be executing. So first point is that extract process is not interacting directly with the database. It is capturing all the transactions from the online redo log files. And the second one is extract process or collector processes, a process or replication process, a replicator. These will not directly, those are background processes which are running from the Golden Gate software. So this is also one more advantage over here. So in earlier case in streams, what is happening is collector process, capture process, and propagators and apply process. Those are based out of PL SQL programs. There is nothing but a procedures or functions. So those will be executing at a database level. So definitely there will be overload on the database. But whereas in Golden Gate, our extract or collector or our replicate process, those are background processes which are running from Golden Gate software, not from the Oracle software. So there won't be any overhead on the database. So that is the main advantage. Okay. Now, in the similar way, in the same way, the way how it has been configured in the Golden Gate, the same way Shapelex also works. Mostly it will not interact directly with the database and it has its own component. So Shapelex is also having good performance as compared to streams. So I'm not going to discuss much about the Shapelex. Just I given an overall view about the Golden Gate, and earlier I given an overall overview of streams. Okay. Now, you people might have heard about one more component in database, that is nothing but a data guard. What exactly the difference between this data guard and our Golden Gate or streams? The difference is data guard is disaster recovery solution. Okay, with this one also we can achieve replication up to some extent, but not flexible, not as flexible as Golden Gate. I am going to explain how it is happening in Golden Gate, data guard, and I will give you a little bit about Golden Gate, so that data guard, so you will have an idea. In data guard also we will have source machine. Users are performing transactions over here. So the transactions will be recorded into the redo log buffer RB, and the transactions will be pushed to online redo log files, and after that the transactions will be pushed to archive log. So this is the source mission, we can say. We will have a target mission over here. Suppose if it is a physical standby configuration, what happens is the archive logs will be pushed to the target mission. What happens is that the changes will be captured from archive log. Whatever the archive logs files will be there, those will be pushed to the target machine, and those will be applied using recovery technology. Recovery means each transactions will be applied using this recovery methodology, whatever we used to do for recovering the database. So this is a physical standby. Here means physical standby. Here means the application will be done. The changes will be applied using recovery mechanism. So here also we are synchronizing both source as well as target, but we are synchronizing at whole DB level. We cannot synchronize particular schema. We cannot synchronize particular tables. Whereas with replication with the Golden Gate or Shapelex, we can synchronize whole database, or we can synchronize whole schema, or we can synchronize a particular tables with Golden Gate or streams. But whereas with the Golden Data Guard, we cannot synchronize particular schemas. we cannot with data guard we cannot synchronize particular schemas or we cannot synchronize particular tables. So that is a limit in Golden Gate. And second one is this data guard basically used for disaster recovery. Means if something goes wrong to this whole database in the primary side, immediately you can bring up the target database so that users can continue to access their data from target machine, or that is a physical standby we can say in the data guard technology. So this is a limitation with data guard. The limitation is we can replicate, we can synchronize the target database with a whole database we can synchronize, but not particular schemas or not particular tables. So that is the limitation with data guard. So I hope you might have understood the difference between Golden Gate replication with data guard replication. So conclusion is that through data guard also we can implement the replication, but the replication happens at whole database level, not at a schema or table level. So that is a limitation with the data guard. Whereas with Golden Gate we can implement the replication the way how we want. Either if you want to implement it at a database level or schema level or table level, you can implement. You can have a flexibility. The same with the streams and other tools like SharePlace, etc. Okay, so far what I did was I given an overall idea about the replication, what exactly the replication and why we are going to use replication in a day-to-day scenarios, and how replication works in a generalized way. And after that I given you a brief idea about implementing replication using streams. I given a brief idea to you. After that, I given a brief idea about how replication being implemented using Golden Gate, and just now I explained you what exactly the difference between Golden Gate and to the data guard. Okay, so this is about the general information about our replication. Now I would like to start with Golden Gate in more details. Okay, so first let's discuss about what are the components available in Golden Gate, and after that we will discuss about architecture of Golden Gate, and next we are going to discuss about what is the initial load and what is the change synchronization. So today I am going to give a brief idea about the what are the components available, and in the next session I am going to discuss about the overall architecture. It's already something close to like 9 o'clock. So I would like to wind up in 10 minutes. So to cover in the next 10 minutes, I'm going to discuss about the components, and if possible, I will start with the architecture today. And the next session, I'm going to cover about the initial load and change synchronization and different methodologies, whatever we can implement using Golden Gate in the next session. That is also mostly going to be a theoretical part. Okay. Okay, this is the diagram about the Golden Gate architecture. So before going about Golden Gate architecture, I am going to discuss about various components available in Golden Gate. Then we will discuss about the architecture in detail. Okay, so before going about this component, just I would like to give one more update, one more point on Golden Gate. So for example, let me switch back to the notepad. Okay. Suppose we have source mission over here, we have target mission over here. This is the source DB and this is the target DB, and we need to implement the replication between these two missions. Sorry, either way, we can say one way or unidirectional, bidirectional, whatever it may be. Replication we need to implement. So both are running on a different mission. This is running on some XY, some host 1, and this is running on host 2. Okay. Say, suppose if I need to implement a replication on these two missions between these two databases, what I have to do is, first step is I need to install Golden Gate software on source mission, on target mission. So I have to install Golden Gate software on source mission as well as the target mission. So once I install Golden Gate software on both the locations, based on business requirement, we are going to design how we need to implement Golden Gate, like whether it is a bidirectional or whether it is a unidirectional or it is a distributed or like any other architecture, whatever the way we need, we are going to configure Golden Gate accordingly on that mission. Okay, so this is about the installing the software. So I'm going to cover how to install software, Golden Gate software in the next session, not tomorrow, in the next weekend I'm going to cover. Now we are going to discuss about different components available in Golden Gate. The first component in Golden Gate, the main important component is manager process. So manager process is a background process in simple term we can say, and which controls rest of the components available in that Golden Gate. So suppose if you have Golden Gate installed on two missions, means in each mission, wherever you install Golden Gate, there will be one manager process. So it controls all the components configured on that mission. Say for example, you configured Golden Gate on source mission as well as target mission. So what happens is that one manager process will be running on the source mission and another process is going to run on target mission. So the manager process is a very important process, and it controls all other components configured on the Golden Gate, configured in the Golden Gate. And it keeps it logs all the changes whatever happening at Golden Gate level. So suppose if any particular process becomes abandoned state, automatically it writes the information into particular log file. It is similar to alert log in the database. In the same way, if any process goes down automatically, what manager does is it brings up that particular component if we specify to auto start. Okay. Similarly, there are many advantages. There are many functions by manager. We are going to discuss each in the later part. And the second component in Golden Gate configuration or Golden Gate architecture is extract process. Generally, extract process we are going to configure in the source mission. Source mission means here we are going to configure the extract process. Why extract process we need to configure in the source mission is we need to capture the changes, we need to extract the changes from the source mission. So that is the reason we are going to configure the extract on the source mission. And the next component is collector process. So this collector process we are going to configure in the target mission because it has to collect the changes whatever extract is pumping to collector. So for that reason, where we will configure this collector is, we will configure the collector in the target machine. So it keeps collecting the information whatever extract sends. So we will configure it in the target machine. And the next point is extract files. So extract files, what happens is like extract files or trial files we can say. There is a slight deviation in this wording. We can say trial files only, we can say for timing. Trial files means this is nothing but our regular file, but it is generated by Golden Gate processes like extract or collector process, which captures all the changes done to the source machine. So what happens is that whenever collector receives any changes from the extract, what it has to do, it has to push it has to write into some files, that is nothing but a trial files. Suppose if the collector is writing changes into the trial files, means those files will be called as a remote trial files. If extract is writing the trial files, means those will be called as a local files. Let me explain you over here itself. Okay, here suppose if extract is there, suppose if it is writing to trial files, means those will be called as a local trial files. In other way, suppose if extract is sending the transaction details to collector process and collector is writing those details into trial files, means these trial files will be called as a remote trial files. Okay, and this is nothing but a regular files, but that is in specific to Golden Gate. Next one which I am going to discuss is replicate process. Okay, always replicate will be configured in the target machine. What it does is, whatever the trial files generated by collector, the replicate process will read those trial files. Sorry, first replicate we will configure in the target machine. And what this replicator does is, it reads the trial files generated by collector process and it will apply on the target machine. Okay, so the replicator reads the remote trial files and it applies on the target machine. So the replicator will be configured on the target machine. So in this example, what I explained about the extract file, and earlier I explained about the manager process over here. In the source machine, one manager process. In the target machine also I explained about the manager process. After that I explained about the extract and collector process in the target, and trial files in the source as well as trial files in the target I explained, and I explained about the replicate process. So these are the main components which are required for implementing a Golden Gate replication. However, there are additional components also available, like data pump. Data pump checkpoints also. There is one more technology. One more component which I am going to explain. Data pump is one more component. It is also similar to the extract or collector, one process which will be running on the source machine, but it is an optional component. There are different ways of implementing chain synchronization between source and target machine. So one way is directly extract is sending the details to the collector. The other way is extract is going to write the trial files in the source machine, and data pump is going to pump those local trial files to collector. So that is another way of implementing the chain synchronization, which I am going to discuss those details tomorrow. So checkpoints, just I will give you a little bit about the checkpoint. Checkpoint is one component. Basically, it will be used by replicator process. in order to track what are the changes have been applied to the target mission and what has to complete. So it's like similar to our database. We can say it is a placeholder which will be updated by replicator process. So what replicator will do? Replicator keep monitoring this trial files, and it will keep updating to the checkpoint. Okay, I completed these files up. I completed up to this point. So it's a kind of tracking mechanism through which we will implement using checkpoint files. Okay, so this is about today's session. I mean, this is about all the components. So I am thinking to conclude up to this point. So tomorrow I am going to discuss about the architecture, little bit more details, so you will have a better idea. So, and I am stopping the recording also now, and which will be shared by Narasimha.